Hello everyone, a big hi to all my bacha log. Jaldi se jaldi everyone come and join the class and let's make this class super awesome, right? If you're seeing me for the very first time, this is Ameer, your physics educator at Unacademy, and those who love me more, they simply call me Bhaiya. Now tell me what we are gonna do today. We are gonna make one of the toughest chapter of class 11 so easy. Which chapter I'm talking about? Thermal properties of matter. How? By making a very quick revision of this particular part, right? Matlab, when I say about quick revision chapter, right, quick revision session, we'll be mainly going through all the important formulas, important definitions, okay, and very important concepts will be discussed in today's class. So everyone, give me a hi once again. Everyone in the chat box, tell me how are you all doing and how much excited you all are for the session. Madan, hi, hello. Secret girl, hi. Honey. Then Sumit, half engineer. Okay. Real queen. Everyone, hi. Everyone just come here and let me know how much excited you all are. Very excited, honey. Very good, very good. Good evening, Vidhi. Okay. Hi, Sudeep. Good to have you here also in our 11th standard class also. Yes, I'm so bilkul badhiya. If you are seeing me for the very first time, a bit of introduction about myself. I hope you all can see it from the screen, right? What is not written here is, Mera bacha log, I'm from Kerala, okay? So I'm not so good with the language of Hindi, but I'm still learning it. I'm trying to improve it in the best way possible. I'm not in a state है ना, so that I can explain the concepts of physics in Hindi to you. So we'll be doing all the explanation in English and बीच में थोड़ा थोड़ा हिंदी में भी बातें करेगा. Like I say in all my classes, right? Okay. Moving on. Now this is the Telegram link for joining the Telegram channel, because it is in this channel where all the updates about whatever happens in our YouTube channel is given. So don't miss out. Link is given here and also in the description box. मेरा बच्चा लोग ठीक है. Bugs Bounty क्या है? अरे it's an amazing program which can help you to grab a lot much of prices. What do you have to do? You just have to go to the link there, okay, in the description box. There you can find a link for Bugs Bounty. Fill the form if you are finding any inappropriate content in the videos uploaded by Unacademy. Valid हो जाए तो क्या मिल जाएगा? चलो बहुत सारा prizes मिल जाएगा for every one of you. So don't miss your chance to grab some prizes. Now देख लें हमारा पास क्या आ गया, Unacademy Combat Scholarship Test. So those who haven't wrote this is your time, मेरा बच्चा लोग. Everyone come and enroll for this, register for this. And for registration, you may think that अरे बहुत सारा पैसे हो जाएगा for the scholarship test. अरे नहीं, it is going to give you lot much of money and prizes, and registering this is completely free. And in order to get free enrollment, you simply have to put this while registering for the scholarship test. क्या है हमारा कोड AMB10 है ना, entire physics family का कोड है AMB10, यूज कर ले, free registration. Now once you write the scholarship test, what you're gonna get, मेरा बच्चा लोग देख ले. For the first rank, if you become, gold medal मिल जाएगा, second rank को silver medal, rank 3 को bronze medal. I haven't completed. If you are one among the first rank 3 है ना, you will be given 1 year of Unacademy free subscription. और क्या चाहिए? Others don't worry, for a rank of 150 till you will be given scholarship. देख ले, awesome. So I think nothing is going to stop you from joining this. We all are expecting you. So come and join, be a part of Unacademy family as soon as possible. ठीक है? Now, moving on. How many of you have already shared the classroom to all your friends? Those who haven't, this is the time, मेरा बच्चे लोग. जल्दी से जल्दी share the class to all your friends and ask them to join. Tell them that Bhaiya has started the revision of thermal properties of matter. It's a very important. If you want to make a quick revision, this is your time. In 1 hour, we'll make the complete revision, right? So Shreya, Anshika, Sudeep, Sena, Amit, everyone, you all can do that as soon as possible right now. Okay, fine. Okay. Now, in the meanwhile, whoever is new to this Unacademy platform, I'll give you a brief introduction, okay, about our Unacademy Plus subscription platform, or what all you are missing if you still haven't made the subscription. We all are learning through YouTube nowadays, right? Yes, it's an awesome thing. I do appreciate that. But there are something which you all are missing if you are not a part of the subscription platform. What all are they? There are some students, right, who would love the direct personal care from the teacher, personal mentoring, personal guidance, right? So this can be made possible once you're a part of the Unacademy Plus subscription platform, because there we have the live chat box where you can interact with your teacher. Again, there we have the questions tab where you can upload all your doubts and get it cleared on the spot during the live class. Still, your doubts are not clear, there is an option called as in-class calling facility. You can call the live educator and ask your doubt and get it cleared during the live class itself. और क्या चाहिए? मतलब just the moment you come out of the class, you'll be having zero doubts and full of concept on whatever you have learned on that day. So isn't that simply amazing? And that can happen once you're a part of the Plus subscription platform. More things are there. Top educators of the country are waiting for you, to teach everything whatever you want in your life. Because of their huge experience, they'll be able to tell you what all examination pattern you should be expecting, right? What all questions you should be doing so that you can make the best preparation for the term 2. Everything will be told to you. क्या करना है आप लोगों को? Just move it accordingly, okay? Just do the things accordingly. You will ace in all the examination whatever you write, okay? You'll get into the colleges whatever you're dreaming about. और क्या चाहिए? देख ले. Study materials are given, practice tests, live test series. Everything is going to make you super awesome, मेरा बच्चा लोग. Now, if you go for 12-month subscription, it will cost you 1,250 per month. Now, देख ले, if you want 10% of discount from this, use हमारा code. Code क्या है? It's AMB10. Use it, get 10% of discount and enjoy your life being a part of an Academy family. Now, एक और subscription है मेरा बच्चा लोग, Iconic. In Iconic, you will get all the features of Plus, some extra features such as a personal mentor. Matlab, a person will be assigned to you for all your academic activities. For every planning of your academic things, this person will be there. Nowadays, we are spending a lot of time on academic planning, how to study, what to study, okay, how to complete all the backlogs. Everything, this person will be there. You'll feel so comfortable. Asani se you can complete your studies when this person is there. देख ले, live doubt solving classes are there. Weekly reports will be given to you. Now, if you're going for 12 months, it should actually cost you 2,333. But है ना, हम तो physics लोग हैं, right? ठीक है, हमारा पास code है AMB10, 10% of discount and maximum offers while you make the subscription. Now, one more thing, बच्चा लोग, I'm a part of the Spark batch, which is happening on an Academy platform. If you want to be a part of this particular batch, let me tell you, from 25th of Jan onwards, which means this Tuesday, a new chapter is going to start there, which is oscillation and waves. You all can come and join for this particular batch, है ना बच्चा लोग? So the link is given on top of the chat box. Can you all see that? Link तो दे दिया है. Click on that link and you all can join this class. Now, one more thing, while joining, don't forget हमारा code है while making the subscription AMB10. ठीक है? So code is given on top of the chat screen. Click on that, be a part of the class. ठीक है? Now, right now, if you make the subscription, extra 3 months is given. So only valid for 500 subscribers. Don't miss it. Okay? वक्त आ गया मेरा बच्चा लोग हमारा क्लास शुरू करने के लिए. आज बहुत सारा क्लासेस था मेरा बच्चा लोग, बहुत thirsty है. Anyway, okay, so tell me everyone, Sudeep, Kezia, Honey, then Sena, Bhumika, are you all ready for the classes? Everyone, are you all ready? So if you all are ready, take a short notebook, take a pen, start writing down everything that is being discussed, because this particular session will help you to make a simple short note for this particular chapter, because we'll be only discussing the important points from this chapter. ठीक है? So Bhumika, Anshika, Vaini, Vidhi, Kezia, Shruti, Bhumika, then Sumit, everyone is super ready, right? ठीक है? So let's get started with the very first topic. Temperature क्या होता है? What is temperature? Right? Temperature is a physical quantity which points how hot or how cold a body is. ठीक है? If a body is very hot, it will be showing a high value of temperature. If a body is cold, it will be corresponding to a low value of temperature. We all know that we have different scales है ना, for expressing the temperature. Which all are the different scales that we have for expressing the temperature मेरा बच्चा लोग? First one, that is Kelvin scale. अरे red तो अच्छा नहीं. First scale what we have is मेरा बच्चा लोग Kelvin scale. याद है? ठीक है. Now in Kelvin scale, what is the freezing point of water? Freezing point of water is actually 273 approximately, and the boiling point of water कितना होता है? 373. ठीक है? Now we have another scale which we call it as Celsius scale. Now in Celsius scale, the freezing point is given as 0 degrees Celsius. ठीक है? And boiling point of water कितना? 100 degrees Celsius. ठीक है? एक और है बच्चा लोग which is Fahrenheit scale. Tell me, here freezing point is given at 32 degree Fahrenheit and boiling point is given as 212 degree Fahrenheit. ठीक, ये सब लोग आपको पता है. And there is one more thing that we know from the initial part, the conversion, right? So how can we convert from Kelvin scale to degree Celsius scale? So degree Celsius is equal to K minus 273. From K, if you subtract 273, you will get the value of the temperature in Celsius scale. Fahrenheit and Celsius relation क्या है? So Fahrenheit degree Celsius is equal to 5 divided by 9 inside the bracket F minus 32. So if you know the value in one scale, you can convert into other. ठीक है? If you all can note it down, it will be better. And it will be better if you can note it along with me. How many of you are noting along with me? Whenever I say something, Zana, whenever I am dictating you something, how many of you are noting along with me? बोल दे. Sana, Honey, Kezia, who all? Noted? Very good. भूमिका, ठीक है, बढ़िया बात है. नोट कर रहा है सब. ठीक है. Yes, awesome. Okay. So let's proceed further. Now, what we should be knowing is heat. अरे heat क्या है? Is heat and temperature the same thing? नहीं. Temperature is a physical quantity to express, right, the hotness and coldness of a body. And heat is what? It is a form of energy, right? An energy which will be transferred from a hot body towards a cold body whenever there is a connection between them. That energy को we call it as heat energy. ठीक है? Clear, right? No issue in that. So temperature measures hotness and coldness, and heat is a form of energy which transfers from the hot body towards a cold body. So this is how we can define temperature and heat. Fine? Okay. So clear है ना? Temperature क्या है? Heat क्या है? दोनों ठीक है? सही है? Proceeding further. Now, this is the portion where you can expect so many numerical questions. Thermal expansion. The word itself will give you an idea, है ना? What we are talking about. What we are talking about? Yes, the increase in dimension of a body when temperature of the body is increased. Right? Whenever we are heating up any body, ठीक है? Whenever we are heating up any body, we will see that its dimension will increase. Dimension मतलब its length can increase, its area can increase, or its volume can increase. If there is an increase in any of these things, we will say that a thermal expansion has happened. We are classifying into three according to the increase or according to the change in dimension. So if you are providing heat energy and if the length is increased, we have linear expansion. If area is increased, we have areal expansion. If volume is increased, we have volume expansion. Fine. Now we will find out the equations for linear, area and volume expansions separately. Okay. देख ले. I'm sorry. Everybody, listen here. Let's say you are having a body of initial length L0. Do you know what I'm doing? I'm going to increase the temperature. Now, the change in temperature is delta T, let's say. Tell me what happens if I increase the temperature of the body. Array, it's very simple. क्या हो जाएगा? इसका length will be increasing. Let's say the increased length is equal to delta L, okay, and the new length is L. Initial length was L0. Now the total final length is L. Increased length is delta L. What will be the formula to find out final length L if we know the initial value of length L0? Formula ये ऐसे है कि L equal to L0 into 1 plus alpha delta T. Delta T is change in temperature, L0 initial length है. ठीक है. Sir, बोल दे alpha क्या है? This is something we haven't seen before. Alpha is temperature coefficient of linear expansion. Okay, it is the temperature coefficient of linear expansion, that is called as alpha. And this alpha है ना, it will be a constant बच्चा लोग. It will be a constant for a given material. मतलब if an ion is given, right? Okay, the ion will be having a specific value of alpha. Now if I am given steel, steel will be having a specific value of alpha. इसका मतलब alpha depends upon the material what we are using. Okay. Third thing, right? Sir, ये alpha, what does it talks about? Okay, alpha tells you the ability of any material to increase its length whenever the temperature is increased. The ability of any body to increase its length. मतलब ये कि those body which has large value of alpha, the increase in length will be larger for a unit change in temperature. Those material which has chotu value of alpha, the increase in length will be chotu for a unit increase in temperature. ठीक है? So it actually talks about ability of material to increase its length. ठीक है? Now I have explained this linear expansion in detail so that the remaining things, मतलब areal expansion and volume expansion, seems very easy to you. Same concept, because instead of length their area and volume will be increasing. That's it. नोट किया ना सबने? जल्दी नोट कर ले. Note कर ले everyone. Is everything fine here in our chat box? Sudeep, Kezia, Sana. Okay. Yes, obviously it varies with material. मतलब each material will be having a specific value of alpha. ठीक है? Good question, Sanju. I think I have explained it. देख ले, I have written constant for a given material. Okay, fine. Yes, all good. ठीक है. Now let's proceed further. Just like linear expansion, we have areal expansion. I think you don't need an introduction for this areal expansion and what it is. देख ले. You have a body, okay, a plain body you have with an initial area of A0. You increase the temperature by a value of delta T. A change in temperature has been brought delta T. So to this area, what will happen? The area of the body will increase. देख ले. Let's say this is the new area now. Formula will be A is equal to new area is A0. Same format. 1 plus, instead of alpha delta T, this will be beta delta T. Bas. Okay, instead of alpha there, here it is beta. So all the remaining properties are same. This is called with temperature coefficient of aerial expansion. Okay, beta, the other one was called as temperature coefficient of linear expansion, ये temperature coefficient of aerial expansion. Bas, that's only difference. ठीक है, alpha talks about ability of the material to increase its length. Beta talks about the ability of the material to increase its area. That material which has large value of beta will be having large ability to increase its area. That's it. Same concept, so same है. There is a simple relationship between this beta and alpha. क्या है? Beta is equal to 2 times alpha, because in some questions alpha will be given where you have to use the equation with beta. So there you can find beta by multiplying alpha with 2. हो गया काम? Now I think I don't even need to tell you ये volume expansion क्या होता है. क्या होता क्या है? अरे increase in volume, right? देख ले, you have initial spherical body of volume V0, you increase the temperature by delta T, volume तो increase हो जाएगा, new volume is V. Formula क्या होता है new volume का? See, V0 is equal to, sorry, V is equal to V0 into 1 plus gamma delta T. गामा क्या होता है? नाम क्या है उसका? टेम्परेचर कोएफिशिएंट ऑफ वॉल्यूम expansion. बस, it will be constant for a material, and that material which has large value of gamma, its volume will be increasing to a large value for a unit change in temperature. बस रिलेशन चाहिए ना गामा और अल्फा का. गेस कर ले, गामा will be equal to 3 times alpha. बस टन टनाटन, टन टनाटन, डन डनाडन. Clear? Clear? All the expansion that we have discussed, it's very important. Sanju, Hani, Bhavana, ठीक है, Sana, Sakshi, Kezia. जल्दी से everyone just copy it down. Everyone copy down करके बता दे, हाँ सर मैं तो कर दिया, हाजिर हूँ, मैं तो कर दिया, मेरा नोट तो कंप्लीट हो गया इधर तक. राइट भूमिका, हितेश, सुदीप, यस, टन टनाटन. ओके, पूरा का पूरा नोट किया है ना? सर खेजिए बन. ठीक है, फाइन, मूविंग ऑन. ओके, यस, देख ले एवरीबॉडी. थर्मल स्ट्रेस एक छोटू सा नन्नू सा मुन्नू सा टॉपिक है. आई टेक अ न्यू पेज एंड आई एक्सप्लेन. एवरीबॉडी लिसन हियर. व्हाट इज दिस थर्मल स्ट्रेस वाला कॉन्सेप्ट? वी नो दैट if we have a body of length L and if we increase the temperature, obviously iska length will be increasing, right? Let's say the increase in length is delta L. Okay, let's make a formula for this delta L. We don't know the direct formula for delta L, but we know that the final length L is equal to initial length L naught into 1 plus alpha delta T, right? L naught, take it to the left hand side. L by L naught is equal to 1 plus alpha delta T. Take this one to the left hand side. L by L naught minus 1 is equal to alpha delta T. Cross multiply kar le. L minus L naught. What is L minus L naught? From the total length L, if you subtract L naught, क्या मिल जाएगा? The increased length delta L. ठीक है? So I'm keeping it delta L by denominator पे L naught is alpha delta T. Who knows ये क्या है? मतलब delta L by L naught क्या होता है? How many of you know? Change in length to original length is called as change in dimension to original dimension. This is strain, right? Longitudinal strain. याद है? मतलब if we are giving a temperature change to the body, there is happening a strain to the body, and the value of strain delta L by L naught is alpha delta T. Keep it there because we need to come to a final topic of what is called as thermal stress. Okay. Same rod मेरा बच्चा लोग, same rod with an initial length of L naught. Now you are keeping in between rigid walls. Okay. Rigid wall matlab it will not be moving. Now to this rod है ना, I'm increasing the temperature. Tell me what happens when the temperature is increased. This length है ना, this rod will be having a tendency to increase its length. But will the walls be allowing it? No. So a force will be developed inside this particular rod, okay, in order to push away this walls and to increase its length. Matlab an internal force is developed here. This internal force per unit area, what do we call it? Stress, है ना? And this stress is produced by change in temperature. So we call this stress as thermal stress. Okay. How many of you do remember this formula? Young's modulus is equal to stress divided by strain. So stress is equal to Young's modulus into strain. Yaad hai? So thermal stress can be written as Young's modulus into strain. Strain, sigma nahi. Young's modulus into strain. Young's modulus, we will keep it as such. Strain, do we have the formula? Delta L by L naught, strain is equal to alpha delta T. So thermal stress का formula हमको मिल गया. What is it? Young's modulus alpha delta T हो गया. The formula for thermal stress. आ गया समझ सबको? आ गया समझ? ठीक है, ये तो छोटू सा नन्नू सा टॉपिक था. ओके, वेरी इंपॉर्टेंट बिकॉज आई हैव सीन क्वेश्चंस है ना व्हिच इज कमिंग बाय कनेक्टिंग. हमारा सॉलिड्स चैप्टर याद है वेयर वी हैव एक्चुअली लर्नड द टॉपिक ऑफ स्ट्रेस एंड बाय कनेक्टिंग दिस चैप्टर. वेरी इंपॉर्टेंट. ओके, नोट किया ना सबने? एवरीबॉडी नोट कर ले जल्दी से, इट्स वेरी इंपॉर्टेंट. दैट्स व्हाई आई मेड दिस डेरिवेशन आल्सो. एक्चुअली इट्स अ रिविजन क्लास वेयर वी वोंट बी डूइंग एनी डेरिवेशन, बट स्टिल. कैन आई प्रोसीड? Specific heat capacity, what it is? What is specific heat capacity? Right, everybody, I'll write the heading specific, ठीक है, heat capacity. क्या होता है मेरा बच्चा लोग? Specific heat capacity which is represented with छोटू s. देख ले, I'll give you an idea. I'm taking 1 kilogram of a body. I'm increasing its temperature by 1 degree Celsius. Don't we have to provide heat energy for increasing the temperature? Yes. So the heat energy provided to increase the temperature of 1 kilogram of a body by 1 degree Celsius, we call it as specific heat capacity. Once again, what is specific heat capacity? The heat required, right, for a unit mass of a body for a unit change in temperature, we call it as specific heat capacity. ठीक है, let's say that heat energy given is represented by the symbol of delta Q. So specific heat capacity is heat energy per unit mass per unit change in temperature. This is defined as specific heat capacity S. Okay, done. Specific heat capacity, heat energy per unit mass per unit change in temperature. ठीक है. Now from here, if someone is asking the value of delta Q, you can easily find out the heat energy required for a body of mass m to make a change in temperature of delta T. Cross multiply m s delta T. So if specific heat capacity of a body is given, we can find out the heat energy of the body of mass m when it makes a temperature change of delta T. Simple बात है. Okay, moving on. Now एक है molar heat capacity. Okay, molar heat capacity. Okay, होता क्या है? usually represented with C. That is equal to the heat energy. The other one was per unit mass per unit change in temperature. Here it is per unit mole per unit change in temperature. Matlab, if I take 1 mole of a body and if I want to increase the temperature by 1 degree Celsius, the amount of heat energy given is molar heat capacity, which we represent it as SSC. ठीक है, heat energy per unit mole per unit change in temperature. ठीक है, एक छोटू सा नन्नू सा टॉपिक है. Let's not go for the next page. That is heat capacity. Heat capacity. So which is usually represented with capital S. What is it? If I take a body of mass M, not 1 kilogram, body of mass M, I want to increase the temperature by 1 degree Celsius. That is heat capacity. Matlab heat capacity is the heat energy required for a body of mass M to make a change in temperature by 1 degree Celsius. Matlab the heat energy per unit change in temperature, delta Q by delta T is heat capacity. Matlab without the word specific S. Now how can I represent this heat capacity and specific heat capacity? Simple. Because we know that specific heat capacity is equal to delta Q divided by M delta T, right? So heat capacity is dekh le delta Q by delta T. So chota s is equal to this bada S divided by M, or bada S is equal to M into S. Bada S is equal to M into chota s. Bada S corresponds to heat capacity. Heat capacity is equal to mass into specific heat capacity. ये भी बहुत important है. ठीक है? नोट कर ले एवरीवन. हो गया नोटिंग? अब्दुल, रहीम, सना, देविका, हनी, खजिया. ओके, साक्षी. हो क्या रहा है इधर? Everyone is having their own chats. मजा कर रहा है क्लास पे. अरे नोट कर रहा है ना सब. I hope everyone is noting down. All these are very important points. आ गया समझ भूमिका, हनी, साक्षी? बता दे, आ गया तो आ गया, समझ तो आ गया या नहीं आ गया? बता. ऑल माय बच्चा लोग, आ गया तो आ गया, समझ तो आ गया? राइट, यस भूमिका. ओके, वेरी गुड वेरी गुड वेरी गुड. बहुत बढ़िया बात है. नोटेड, राइट? यस 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 भैया, मनसिलाई. ओके, वेरी गुड वेरी गुड. Yes sir, all Malayalam, Tamil, Hindi, Telugu, all language mixed together. Okay, the life is all about learning new things. So I am, after coming to an academy, what I am doing is learning new naya languages here. Anyway, moving on. Left, all these are discussed. Now, calorimetry kya hota hai? The word calorimetry means the measurement of heat, right? So which heat are we going to measure? Let's see. Take le. Everybody listen. Very important topic. Calorimetry. होता क्या है ये calorimetry? Everybody listen. देख ले. We are having a hot body. Okay. A hot body I have. Let's say it is having a mass of M. Its specific heat capacity is equal to SH. To correspond a hot body. ठीक है? And let's say it is at a very high temperature, TH. Now this hot body is mixed with another cold body. Mass is MC, इसका mass is MH. ठीक है? इसका specific heat capacity is MSC. ठीक है? And temperature is TC. To correspond that it's cold. देख ले. You are going to mix these two bodies. ये hot body and cold body, you're mixing it together. Tell me what happens. Once you mix hot body and cold body, we simply know the heat energy, right, will start flowing from the hot body towards the cold body. Until when? until both of them achieves a common temperature, because heat energy transfer happens because of this temperature change. Now heat energy keep on transferring from hot body towards a cold body. क्या हो जाएगा? Temperature of the hot body will decrease. And what about temperature of the cold body? It will increase. One will decrease, other one will increase. Decrease, increase. At a particular time, both of them will be having the same value. Right? So this heat energy transfer happens once both of them have the same temperature. Okay? So we understood the hot body release energy and the cold body absorbs energy. And we also know one more thing. What? The heat energy released by hot body is directly given to the cold body. So what can we write? Delta Q, the heat energy released by the hot body, is equal to the heat energy absorbed by the cold body. Delta Q cold. How can we find out the heat energy released? देख ले, from a higher temperature it is becoming a temperature of T. What is the formula? याद है? The formula is equal to mass of the body, that is mH, specific heat capacity of the body into change in temperature, Th minus T. If a hot body make a change of temperature from Th to T, the heat energy released is this. How much will be the heat energy absorbed by cold body? देख ले, mass of cold body, specific heat capacity of cold body, from a lower temperature of Tc, it becomes T right now. So the change in temperature is T minus Tc. Are they equal? Yes, they are, because we know that heat energy release is equal to heat energy absorbed. Very important concept. ठीक है? Very important concept it is. We all know, right? ठीक है? Note कर ले ये. This is equal. This is okay. If you want me to write the same formula on the right hand side, this will be equal to mH sh Th minus T is equal to mc s of c T minus Tc. नोट कर ले, पूरा का पूरा नोट कर ले बच्चा लोग, बहुत इंपॉर्टेंट है ये कैलोरीमेट्री. All the formulas related to calorimetry and what is the concept happening. All these are very important, let's say, then only we can do any problem related to it. Fine. Sumit, Hani, Kezia. आ गया तो आ गया, समझ तो आ गया बिल्कुल अच्छे से, बहुत बढ़िया से. Yes, noted. Okay. Note it down जल्दी जल्दी सुदीप. ओके. अब्दुल, साक्षी आ गया तो आ गया, सबको समझ में आ गया. राहुल, भूमिका, संचू, अमित, अरे everyone, just can you all come back to our class? Actually we have so many backbenchers here who is having a very good अच्छा conversation in this class, है ना? I'll call out the name just like Sana, Honey. Who else we have? Then I think we have Sudeep. Everyone come back. Okay, let's make this class move forward, right? Okay, now we'll proceed. Calorimetry topic, I hope it's clear. Now, change of state. This is very important. Everybody listen. Change of state concept क्या होता है? Usually, let's say I'm having some liquid in a beaker, right? If I provide some delta Q, matlab heat energy to this particular liquid molecules, tell me what happens. Heat energy will be absorbed by the molecules of the liquid, right? Its kinetic energy increases. Matlab particle will start moving faster once it gets the heat energy. ठीक है? Kinetic energy बढ़ जाएगा. When the kinetic energy increases, yes, the temperature is increasing. So usually when we provide heat energy, it is the kinetic energy of the molecules increases, which results in the increase of temperature. But देख ले, I'm taking a beaker and I am taking some ice exactly at 0 degrees Celsius. And I am inserting a thermometer also. Okay? And I am inserting a thermometer. Obviously, it will also be corresponding to a 0 degree Celsius value, right? Okay. Now, I started to heat this body. Matlab, I started to give heat energy to it. What can we see? We will see that this ice will start getting converted into water. ठीक है, ice will start melting, water हो जाएगा, melting water, this keeps on happening. ठीक है, okay. Now you will be so surprised that during this process, even though ice is getting converted into water, no change will be there in the thermometer. Thermometer will always be showing 0 degrees Celsius. ठीक है, it will be showing 0 degrees Celsius है ना, until the entire ice becomes water. देख ले, until the entire ice becomes water, right? There won't be any change in the temperature of thermometer. मतलब, if temperature is not changing, matlab, it is not the kinetic energy which is increasing, because if it was increase of kinetic energy, temperature would have been increased. But what is happening? Array, here a solid ice is becoming a liquid water. Matlab, solid matlab, molecules will be closely placed like this. Once it becomes water, molecules will be far apart. So when the molecules distance is increasing, potential energy to increase हो रहा है. Yes or no? Yes. So whenever we are providing heat energy to a solid, right, at its freezing point or the melting point, let's say, right, the heat energy is used for increasing the potential energy, so that one state which is solid can be converted into what? To its liquid form. This is the reason the thermometer is showing always the same temperature. समझ में आ गया? Right? Similar will be the case during the conversion of a liquid into the vapor. Same temperature will be remaining, because liquid state is getting converted into gaseous. So whatever heat energy you provide is used for increasing the potential energy. ठीक है, that is a change of state that you have to learn. हो गया बात सबका? ठीक है, सुदीप, खेजिया, everyone. Okay, now देख ले, everyone देख ले, listen. Now what we have to do is, two concepts are there बच्चा लोग. Okay, two concepts. One is latent heat of vaporization and latent heat of fusion. We will write latent heat of fusion. Okay, देख ले, I'm having a solid material, okay, of 1 kilogram. I am converting into its liquid form. So don't you have to provide a heat energy for converting 1 kilogram of solid to its liquid form? Yes. Matlab, a heat energy is provided for a unit mass of a solid to get converted into its liquid form. This is called as latent heat of fusion. Matlab, the heat energy required per unit mass of a body to convert it from solid to liquid is called as latent heat of fusion. Heat energy per unit mass, latent heat of fusion. ठीक है, fine. So what will be latent heat of vaporization? Same. If I have 1 kilogram of a liquid, if I am converting this into the vapor state, okay, latent heat of vaporization matlab the heat energy required for converting 1 kilogram of a liquid into its vapor state. That हो जाएगा latent heat of vaporization. Note कर ले. अरे कितना आसान है, देख ले. Only this much we have learned in this particular chapter, right? If you know all these concepts, doing a problem is not at all a big task. हो गया बात है, हो गया. हनी, भूमिका, साक्षी, सना, अब्दुल, आ गया तो आ गया, नोट भी किया है ना सबने, अरे नोट कर ले। मेक दिस अपॉर्चुनिटी टू मेक योर छोटू वाला बुक, मतलब शॉर्ट नोट बनाने के लिए, है ना? ओके, anyway you are spending time here in this class, so write down whatever is required, then you don't have to spend any other time for making the short note, हो जाएगा आप लोगों का काम, राइट? राहुल नोटेड, भूमिका नोटेड, देविका ओके, पूरा का पूरा लोग नोट किया, राइट? यस 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 सर. വർഷത്തിൽ ഒരിക്കൽ വന്ന്, अरे don't listen to whoever is disturbing you, right Sana? Just stay here, do whatever you are supposed to do, ठीक है? Enjoy कर ले. So Kezia was doing what? Okay, talking. Oh, we all are studying. Okay, the only one person, Kezia, don't disturb the class. मत कर ले आप, ठीक है? Others, everyone, always studying. Very good. I know that all my बच्चा लोग are super good. Shall we continue? ठीक है, देख ले. Okay, ये सब हो गया हमारा. Change of state, latent heat. Okay. Now time आ गया हमारा. Now we know that heat energy will be transferred from hot body towards a cold body, ठीक है? But we don't know, right, how it is being transferred, and that's why we are going to discuss about the modes of heat transfer. मतलब what are the different methods by which heat energy can be traveled from one point to another point or exchanged from one point to another point. Here we go. What is it? Modes of heat transfer. What are the three different modes of heat transfer we have मेरा बच्चा लोग? First one, conduction, ठीक है? Second one, convection, and the third one, radiation, ठीक है? We will start from the first part, which is conduction, ठीक है? Everyone, देख लो. We'll start from conduction onwards. Okay, here we go. Everybody listen. Our naya topic, conduction. What is conduction mode of heat transfer, or when conduction mode of heat transfer will come into play? We want to exchange heat energy from one point to another point of the same body. देख ले. Here we have a rod, ठीक है? At this particular end, I am going to heat the body. मतलब I am going to provide some heat energy. What will happen? This will become a hot body compared to the other end, which is a cold body. Now what will happen? Now the heat energy will be traveling from one point of the body, which is a hot body, towards the other point, which is a cold body. This method of heat transfer, we call it as conduction. ठीक है? Now your easy things will be, sir, कैसे? How the heat is getting transferred? देख ले, whenever we give heat energy, it's a solid, let's say, so the particles will start vibrating. ठीक है? Now one vibrating molecule will transfer the vibration to the nearby molecule. Okay, this will start vibrating. So here the temperature will increase. This will make the nearby molecule to vibrate. Its temperature increases. मतलब it is a vibrating molecule which carries a heat energy from one point to another point. आ गया समझ? ठीक है? How the method of conduction happens, everyone? ठीक है? Now ये भी देख ले. Formula क्या है? देख ले, we have a rod of length L, area A, ठीक है? And change in temperature of delta T. मतलब here it is T1, here it is T2, T1 minus T2. Change in temperature delta TB है across the ends. Now the heat energy traveling delta Q by delta T क्या है? Heat energy traveling per unit time. The rate at which heat energy travel is given by K A delta T divided by L. A delta T and L we already have defined. You will be asking, sir, ये K क्या है? होता क्या है सर ये K? देख ले, K is called as thermal conductivity. याद है? I hope you do all remember ये thermal conductivity क्या होता है, right? It shows the ability of the material to transfer heat energy from one point to another point, to conduct heat energy from one point to another point. मतलब very simple. That material which has large value of K, right, it will be having more ability to conduct heat energy from one point to another point. Simple question. Wood and steel, which one will be having large value of K? Steel. क्योंकि steel has more ability to transfer heat energy through it. बस हो गया, ठीक है ना, right? Ka delta T divided by L. This is the main part from conduction. आप सब लोग लिख रहे हैं ना? Everybody, I hope you all have noted this down. Honey, Sakshi. Yes, right? भूमिका पूरा का पूरा लोग नोट किया. Okay. Now, sometimes some questions can come like this. मतलब we have one rod of length L, area A and thermal conductivity K1. Another rod of same length, area A and thermal conductivity K2. What will be the effective value of thermal conductivity if they are connected in series? The formula is 2 divided by 1 by K1 plus K2. ठीक है? This will be the effective. If they are connected in series, ऐसे होता है. Okay, 2 divided by 1 by K1 plus 1 by K2. Similarly, if two rods of thermal conductivity K1 and thermal conductivity K2 are connected in parallel, effective value of K will be K1 plus K2 divided by 2. ये भी याद कर लें, derivation हम class पे किया है. I hope you do remember. If anybody wants a derivation, I hope you all gonna watch the class, है ना, जो हम किया है. Do watch the class and understand how we have done this particular derivation. बहुत important है, ठीक है? Don't miss it. अभी तक कोई doubts है क्या? Any doubts still here? The chat box is all open. You can ask me, sir, ये doubt है, हमको नहीं समझ में आ गया sir. Any doubts? This is your chance. No? Devika, nothing? Okay, so I hope everything is clear. We'll proceed. Okay, no doubts are there. Everything is super clear. Now I think I can jump to the next mode of heat transfer, which is, बोल दे everyone, convection. Convection. याद है? Convection. What was convection? Right? The mode of heat transfer by actual movement of molecule. मतलब a hot molecule will be moving from one point to another point so that the heat energy can be transferred. Because in conduction, the vibrating molecule it was, right? In convection, the moving molecules will be carrying the heat energy from one point to another point. देख ले, we can say moving molecules carry heat energy. A simple example, if you want me to give you, I can give you this simple thing. देख ले. Okay, you have a water initially. ऐसे you are heating the water by giving some heat energy at the bottom of the container. What will happen, मेरा बच्चा लोग? Tell me. वो क्या हो जाएगा? The molecules at the bottom, which is in close connection with the bottom surface of the container, will get heated up, right? This will get heated up. मतलब it will be having a high temperature. We know that any molecules once they are heated up, उसका density कम हो जाएगा. So the molecules of water or the layer of water at the bottom will be having rho density lesser compared to the upper where it has a more density. More density मतलब it has a more tendency to come down because of its large weight, है ना? So this heavy molecules or high denser molecules will come down, ठीक है, ऐसे आ जाएगा, and this low density molecules will go up. So the heat energy which was only there at the bottom, with the molecules it will be moving up, ठीक है, and this molecules which is coming down will now get heated up. मतलब ऐसे this movement, this cyclic movement of molecules will keep on happening until the heat energy is being distributed throughout. This is convection mode of heat transfer. आ गया समझ सबको? साक्षी, ऋतिक, मिथिलेश, सबको आ गया ना? सच्ची में मुच्ची में convection. There are no equations to be learned from convection part. ठीक है, convection पे कोई formulas कुछ नहीं है, ठीक है, only this concept you have to know. Some sea breeze, land breeze का थोड़ा थोड़ा examples भी दे दिया. You should be doing all those stuff. देख ले. एक और बाकी है, radiation, वो भी करेगा, ठीक है, radiation भी करा दे. अरे we are almost at the end of the chapter, हो गया. I kept your promise, 1 hour पे revision हो जाएगा. I can keep my promise, right? Okay, now I just want to know how many of you have put in your complete effort for learning this. देख ले, last mode of heat transfer, which is radiation mode of heat transfer. What it is? देख ले, everybody listen very carefully. Here we have a hot body. Every hot body will be emitting out its heat energy in the form of electromagnetic waves. All hot bodies will be emitting out electromagnetic waves which carries the heat energy. So a hot body which releases this helium waves which carries the heat energy as say will be received by another body. Okay, let's call it as body B. So it is a body B which receives this EM waves which is coming from this hot body. So here it is the electromagnetic waves which carries the heat energy from one body as say to the other body. A name is given for all these electromagnetic waves. We call it as thermal radiations. Thermal corresponds to heat. Radiation corresponds to EM waves. Thermal radiation, heat EM waves. Okay. EM waves doesn't require any particles to move. Matlab, no medium is required for EM waves for its movement. And because of that, the heat energy by radiation heat transfer does not require any medium to transfer the heat energy. I think you might be wondering, right? How the heat energy produced by the sun was reaching the earth after passing through many vacuum region. Which one? Radiation mode of heat transfer. Simple, right? Okay. Now, the heat energy received by a body totally depends upon the color. Matlab, if it is having a black color, it will be absorbing maximum amount of heat energy. Okay, absorbs heat energy more. Black colors. Okay, that's why when we wear black color shirts during summer season, we feel so hot. Okay, so usually we wear black shirts, okay, black dresses during winter season so that it can keep us warm. Okay, what about white dresses? It absorbs the least. So during summer season, we can wear white shirts, right? Because it will be absorbing only less amount of heat energy, so it can keep us cool all the time. Okay, fine. Now, the just is the case of the heat radiating out. Matlab, you know that it's a black body which absorbs more amount of heat energy, right? Same process, it is a black body, right, which emits out maximum amount of heat energy from it. Okay, if we are having a hot body at a temperature T and a normal body, here we have a hot black body and here we have a normal body. I'll write it down. We have a normal body at a temperature T. You will find out that it is this hot body It will be this hot body which will be emitting out a huge amount of heat energy compared to a normal body at the same temperature. So all the radiations are always compared to a hot body, sorry, to a black body, because it's a black body which emits out maximum amount of radiation from it. Okay? So a small ratio is also being defined on the basis of that, which we call it as emissivity. क्या है? emissivity क्या है? अरे एक छोटू रेशियो है, देख ले. At the same temperature, energy released by a normal body, E released by normal body divided by energy released by black body at the same temperature, right? That ratio we call it as emissivity. Simple. इधर तक clear है क्या? नन्ना मुन्ना बात है. इधर तक clear है everyone? Anas, Mithilesh, Jia, Aryan, Khan, Ketan, right? I'm sorry. बोल दे everyone. Is it clear? इधर तक टॉपिक क्लियर है क्या बच्चे लोग सबका? यस सर क्लियर है. विधि यस, भूमिका, मिथिलेश, सबका अच्छे से, बहुत मजे से, राइट? ओके ओके. हाय अनस मंसूरी, हनी, यस. ओके, लेट्स प्रोसीड. नाउ we will talk about the heat energy released, okay, from a body because of radiation. देख ले, we have a body, ठीक है? A normal body. First we'll talk about a black body. We have a black body at a temperature T. We want to find out the equation, right? The heat energy transferred per unit time, okay, which we usually call it as emissive power. This is usually noted as emissive power. मतलब heat energy per unit time, a name is given, emissive power. That is equal to, for a black body, it is sigma, which is the Stefan-Boltzmann constant, A, area of the body, the temperature, the whole raised to 4. Make sure that it's in Kelvin scale. Okay, fine. Now, let's say it's not a black body, a normal body. Okay, a normal body we have with an emissivity of E. So in this case, dq by dt is, formula क्या होता है? Simply multiply emissivity, remaining things are same. Emissivity sigma A T raised to 4. Okay, let me tell you, these two formulas are used when the temperature of the body is very much greater than the atmospheric temperature. When it is very much higher, we will not be considering atmospheric temperature. If that's not the case, matlab temperature of the body, okay, and temperature of the atmosphere almost same hai. What was the formula we have discussed? Tell me. In that case, formula kya hota hai? So we have a normal body of temperature T, and atmospheric temperature is T naught. In this case, dq by dt is equal to, okay, emissivity sigma A T raised to 4 minus T naught raised to 4. Both should be in Kelvin scale. Okay. This is a formula when the temperature of the atmosphere is also considered. Note it down. All are super important. Fine. And we are almost at the end of the chapter. We have only 2-3 more topics to be discussed. Is it done? हो गया बातें? Mithilesh, fully focused on studies. Very good. Bhumika, yes. Vidhi noted. Yes, sir, noted. Okay. Ritvik, Mithilesh. अरे ऋत्विक, just quick. Formula है और कुछ नहीं. ठीक है? Look into the formula. I didn't say anything other than that. Okay? I just said the formulas in different conditions. Okay, clear है, right? सृष्टि, जिया, भूमिका, ठीक है. We'll proceed. We have 2-3 more topics left. That is it. Now we have a chotu topic which we call as Wayne's displacement law. Wayne's displacement law. Okay, what does it talks about? Take a hot body. Okay, take a hot body. बच्चा लोग, आपको पता है from a hot body EM waves will be emitted. ठीक है. Questions you can ask. What is the wavelength of the EM waves emitted? अरे wavelength of all values are being emitted. Wavelength of all values will be emitted from a hot body. So how can we differentiate, sir? Right? Though all wavelengths are being emitted out, the intensity, or let's call it as brightness, है ना? The brightness of wavelengths will be different. Okay, all wavelengths will be having different brightness or different intensity. At a particular temperature, right, only a specific value of wavelength will be having the maximum intensity. Okay, only a specific value of wavelength will be having the maximum intensity. Intensity maximum. We usually call it as lambda max. Matlab, if we just try to plot the same on a graph, you can have a better idea. देख ले, we are plotting intensity and wavelength. From a body, all wavelengths will be emitted. Okay, but wavelengths will be having different intensity. Matlab, this wavelength will be having itna intensity, this will be having itna, this will be having itna, this wavelength will be itna intensity. Matlab, if you plot a graph will be looking like this. At a particular value of temperature, a single wavelength, देख ले, it will be having the maximum wavelength. Sorry, that wavelength will be having the maximum intensity at a particular temperature. Wayne's displacement law talks about what will happen to this lambda m when temperature is increased. Wayne's displacement law, it was found out that once we increase the temperature of the body, the wavelength correspond to maximum intensity decrease हो जाएगा. मतलब, it was found out that lambda m is inversely proportional to the temperature in Kelvin scale. ठीक है? Now, if someone is asking to draw the graph of intensity versus wavelength at a larger temperature, how will the graph be looking like? Graph कैसे हो जाएगा? देख ले. At a higher temperature, graph will be looking like this. This is at a temperature of T dash, which is greater than T. देख ले. Now, this is the wavelength corresponding to maximum intensity in the second graph. Now, as the temperature T dash was increased, you can see that this wavelength corresponding to maximum intensity has decreased. This is Wayne's displacement law. और कुछ नहीं. आ गया समझ? A small revision part we have done here. Okay. Is it clear, everyone? जल्दी बोल दे. छोटू सा concept था ये, isn't it? Anuradha, have a look at it, everyone. Try to copy it down. समझ में आ गया सना? Very good, honey. Yes, got it crystal clear. So కొంచెం బోర్ ఆగదు. అరే यार क्या करूं मैं? अच्छा explanation. Thank you so much. Okay, so in order to make the session interesting, है ना, Honey is asking, sir, tell us your memorable story. My memorable story will be when we can complete the session in 1 hour, because we started by 10:10 after all the initial promotion things, right? So it is 11:10, 1 hour हो गया. So anyway, two topics are left. Can we do that? फिर उसके बाद हमको खत्म कर सकता है ये. then आराम से you all can go to your sleep peacefully. अच्छे नींद. What do you all say? Got the topic in a very better fashion, Devika. Very good. अरे there are so many people here who haven't still shown some love towards your भैया. क्या कर सकते हैं? अरे move your cursor, click on the like button. ठीक है? Nice story, right? ना? No? You didn't like it? समझ में नहीं आया? अच्छा नहीं लगा आप लोगों को? छोटू story, let me remember. ठीक है? While I remember, I'll talk about the very last topic. ठीक है? The Newton's law of cooling. ठीक है? I'll think about, give me some time, I'm thinking. ठीक है? In the meanwhile, because I'm multitasker, I know multitasking, right? So by the time I think about some story, I'll also explain this Newton's law of cooling also. What do you all say? It's a good thing, right? Two things at a time. Good. देख ले. Newton's law of cooling. हो गया तो हो गया चलो का. Newton's law of cooling. Okay, very simple. We are going to talk about coffee cup. अरे coffee cup नहीं, coffee cup and a coffee. ठीक है. So here we have a cup of coffee, right? Let's say it is at a temperature of T and the atmospheric temperature is T naught. Now, obviously, when this hot coffee is kept in the atmosphere, we know that its temperature keeps on decreasing. Or we'll say that the tea or this coffee will start cooling down. It was found out that the rate at which this coffee cools down is directly proportional to the difference in temperature of the body with the surroundings. Matlab, T minus T naught, okay, it is proportional to what? Or let's say the rate of heat energy or the rate at which a body cools is directly found to be proportional to T minus T naught. When a body cools, matlab, the rate of cooling, matlab, what is happening? Heat energy is being given from the body. Okay? So let's say Q is the amount of heat given. The rate of cooling, matlab, rate at which the heat energy is given. dQ by dt. And what is said? This is directly proportional to T minus T naught. This is Newton's law of cooling. Very simple. Very simple. Now, a small modification to this law can also be done. Do you know in which case? देख ले, everybody देख ले. A chota modification can also be done. Now, this hot coffee, okay, let's say it was initially at a temperature of T1. It cools down to a temperature of T2 when it kept in an atmospheric temperature of T0. In this case, what will be the Newton's law of cooling formula? Very simple. The rate at which the body cools is found to be difference in temperature of the body with the surroundings. Now, we don't have a direct temperature for the body because the temperature of the body keeps changing from T1 to T2. Now, the temperature of the body is taken as the average value of temperature, okay, of the initial temperature and final. So T1 plus T2 by 2 le liya. Done. We can actually support for this also. dQ corresponds to the heat energy released. If a body is changing its temperature from T1 to T2, what is the formula for heat energy released? M. Okay. Then what it is? S, specific heat capacity into T1 minus T2. Heat energy given by a body during temperature change, M as T1 minus T2. Actually, you can substitute that also here. M as T1 minus T2 divided by dt. Proportionality, I'm going to convert into equation by multiplying it with a constant. T1 plus T2 by 2. हो गया काम. ये था हमारा न्यूटन्स लॉ ऑफ कूलिंग. ओके, ये था हमारा न्यूटन्स लॉ ऑफ कूलिंग. जल्दी से जल्दी फटाफट है ना, अच्छे से बता, हाउ वाज द टॉपिक, कितने समझ में आ गया सब लोगों को. Automotive sensor, let it be, Anas Mansoori, let it be, right? Everyone, just yell out and tell me, how was the session? Was it worthy enough? Matlab this 1.5 hours mein, or let's say in 1 hour, right? Okay. We did this complete revision of chapter of thermal properties. So how do you feel? Do you feel like, ha, acha aa gaya, sir, right? It was a very good session. We got to know more about it. Or, nahi, sir, acha nahi tha. This was not a good idea. Okay, these revision sessions are not doing good for us. What do you say? It was very best. Thank you so much, Otav. Amazing. Very good, Gia. I was Newton is still now. Very good. That was a very good joke. I don't know how many of you got the joke actually. Okay, those who have noted down, jaldi se note kar sakta hai. ठीक है, Shiga, honey. Yeah, bilkul, honey. I'll do that. Thank you so much for the care. With the amazing session. Stefan's Boltzmann law is already discussed, Sanjay. We discussed that. Okay, very best. Okay, all concept clear. Bomega, baki sab aaya. Theek hai, amazing session. Thank you so much. Now, moving on. So, that's it. Okay, hamara to ho gaya. All the topics are being done. Theek hai, greenhouse, Newton, blah, 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 blah. Sab ho gaya. Now, those who are still there, who is not a part of my Spark batch, theek hai, you all can come and join because one amazing thing is gonna happen. देख ले फ्रॉम 25th, कलर अच्छा नहीं है, देख ले फ्रॉम 25th है ना, 25th Tuesday we are gonna start a new chapter in the batch, oscillations. I don't want any one of you will be missing this, right? So if you want to be a part of this batch, a link is given on top of the chat screen. How many of you can see that link? Click on the link and you can be a part of this Spark batch. Very simple. Matlab, all things will be explained there in a very much beautiful way, and soon we can learn oscillations and wave chapter there. So don't miss your opportunity. I am expecting every one of you to be a part of this oscillation chapter or this Spark batch. Along with me, you can enjoy the amazing classes of Shalini ma'am who takes biology there, Abha ma'am who takes chemistry there, Anita ma'am with English, and Deepak sir with Maths. So don't miss this opportunity. Okay, everyone can come and join and enroll for this course. Okay, yes. So expecting every one of you. I hope you all can see the link on top of the screen, right? Ek aur link hai, that is the link to my Unacademy profile. So you can follow my Unacademy profile. So whenever live free classes happen, you will be getting the notifications, right? Free classes, even though it's not paid, you can be a part of it. Dekh le. This is the best time to make the subscription. 12 months ka subscription le le, extra 3 months enjoy kar le. Only available for first 500 subscribers. So code hamara AMB10 hai for extra 10% of discount and to get remaining all, let's call it as remaining all super amazing offers to get. Fine. Now बच्चा लोग Unacademy Prodigy का scholarship test हो रहा है. It can help you to get college scholarship. Okay, extra 20 lakh college grants. It starts from 23rd of Jan. If you want to be a part of it completely for free, you can use the code. Once again, हमारा AMB10. Don't miss your opportunities. The date and time for each and every kind of students, you can see it here. And the awesome gifts which you are gonna receive is rank 1 MacBook Air, Apple iPhone for 2 to 3, Apple iPad, Amazon Echo Dot 41-100, and Amazon vouchers will be given. Awesome it is. So class 11 other batches, what is going to happen is that you can see it here. You can enroll it and you can be a part. Special classes features, as you all know, it's so amazing. Now once again, bachalo, those who haven't liked the session, this is your time. Every one of you, this is your time. Just show some love, move your cursor, click on the like button, and just let me know that all these sessions are very much helpful for you, so that I can keep on doing more and more sessions like this. So the main culprit Kizia is here. Please give some care to her like you gave us. I already told, I don't know whether she heard it or not, right? At that point of time. वो छोटे भाई पहचाना क्या, पढ़ने लग रहा यार तू बड़े भाई, keep it up and yeah, sure Kushal. Thank you Vidhi, honey. Story already like किया Devika, very good. Okay, those who haven't shared the class, you all can share it in your school groups to your school friends. ठीक है? Don't forget. So please say you forgot Kezia. Uh, I don't. Okay, some memories are there, I suppose. Okay. Anyway, Vidhi, Unati, Sudeep, she has game. Okay. Okay. Anyway, thank you so much, everyone. Thank you so much for making this class so active, full of energetic. Okay. So thank you so much once again. It's time for me to leave. Bye, everyone. Okay. See you all. Chalte chalte. We'll all see you on Monday. Bye bye.